This is the back page of the notes. One thing you should take notice of is that these are the exact same examples on the front page. On the front page, I solved each of them by expanding them out and then counting how many of each item I had. In this case, we're going to zip through them a little faster and try to work on the shortcut way to solve them. This first one, 7 times 6y squared, numbers times numbers. I'm going to look through here and see what numbers, we're not talking about exponents, we're talking about actual numbers, we can multiply. 7 times 6 is 42. And then we'll scan through for letters. The only letter is y squared, which means 2 y's. So we're just going to zip to 42y squared. The next example is like saying we have 4 z's all multiplied together times 3 z's all multiplied together. In total, we are looking at 7 z's being multiplied together. 4 z's times 3 more z's means that there are 7 z's being multiplied together. The shortcut to take note is that 4 plus 3 is 7. So if you have 2 letters that are the same letter featuring different exponents, you can add the exponents together, and that tells you how many of that particular letter you have. For example, this features a 3, 5 A's here, and 2 more A's. So there are a total of 7 A's. 5 plus 2 is 7. So our final answer is 3A to the 7th. Moving on, 2 times 4 is 8. There are 3 m's and 2 more m's being multiplied against each other. So there are a total of 5 m's being multiplied against each other. There's only a single D in this problem, so we're going to just write D. There are 4 K's here and another single K, which makes a total of 5 K's. If there are no exponents present, you can assume it's an invisible 1. 4 K's plus 1 more K makes 5 K's. For the lengthy problem, numbers times numbers. 5 times 7 is 35. Letters times letters. Over here we have 2 Q's and then 3 more Q's, so there are a total of 5 Q's. Then we have 4 W's and 5 more W's. There are a total of 9 W's. 35Q to the 5th, W to the 9th. You'll notice that this way is a lot faster way to solve these problems, but if the shortcut is confusing to you, it's worth the extra time to expand them out until you get better at that skill. Then you can work on the shortcut. The next one, 3 times 5 is 15. X times x, it's like having 2 single x's multiplied against each other, x squared. So 15x squared. And the last term, 9 times 6 is 54, and there's just a single x to tack on to the end. Again, if you struggle with the shortcut, I would recommend expanding the problems out like we did on the front page. This will take a little bit more time, but it would probably improve your accuracy, and that is worth the trade.